Hi guys, this is for Dr. Annetta's class and we're looking at divergent events, the Lyndi O'Neill way. These are my students, Barin O'Neill, say hi, and Evie O'Neill, say hi.
Hi.
Okay, so I want you to take your lab sheet and Evie, you're student number 1, you're my AIG student, you already wrote your name. You're student number 2, I need you to write your name please. And remember we had just finished, eyes up on me, remember we had just finished talking about the tornado that happened in 2011 when Evie was a baby and we lived in Pope Air Force Base when we had orders to Fort Bragg the first time.
Yes.
So what was significant, what was unique about the fact that that tornado happened? Yes.
Because Yadkin got destroyed.
Because Yadkin Road got destroyed? What else? What time of year did it happen?
It was towards spring, wasn't it?
It was towards spring, in April during our spring break.
Yes.
And what did everybody know that was in the tornado that proved to us that it was a tornado and that it wasn't just a regular storm?
It was dangerous and it was just like a hurricane.
Kind of like a hurricane, the ones our family members had talked about in Florida. But what was unique? What was that spinning thing called that begins with a V?
Vortex.
It was a vortex, okay? And so we had just finished having all this different type of weather in Fayetteville, North Carolina. Now what we're going to do is we're going to try to recreate different types of tornadoes in honor of the weird weather that is in Cumberland County. So we're going to write a P right under each block. We're going to write a P. And our P is going to stand for our prediction. We're going to predict, knowing what we know, knowing what we saw in the video clips, and knowing what we know about real life, we're going to make predictions for each type of tornado that we're creating. We're going to make those predictions to see what's going to happen with each one. Then I want you to take 2 fingers like this, right under the letter P, right under the letter P, and then under your second finger I want you to write R. R is going to stand for our real life result. So we're going to predict, we're going to make a prediction about what we think we're going to observe, and then we are going to write down what we actually observe when we do our little experiment. Okay. All right, so my AIG student, Evie, what does the first column say we're going to do?
It says that we're going to water alone.
So we're going to have this little tiny bottle that has water alone. So I'm going to fill up your little water bottle, and I want you to seal it up real tight, okay?
Yes, ma'am.
Seal it up real tight. And we're going to seal it up real tight. Now, look at the water. Explore the way it looks. Pick it up. Now that you've sealed it up real tight, look at it all around. I'm not going to have you do this yet, but when I ask you to shake it clockwise, just in the way that a clock would move, what do you think is going to happen since there's only water in the bottle?
It's going to spin around just like a tornado.
It won't spin around long.
It won't spin around long. So whatever you think is going to happen, I want you to write that down beside your P. Okay. I'm giving you some wait time. And then I'm going to help you out in just a second. Okay, it's going to spin. All right, so what I want you to do is I want you to take the little bottle and take the bottle and you're going to spin it to the right just like we would in a real clock. Now look at it. See if your predictions were true. Okay, so write down your real result. Now I need a volunteer with a stopwatch. Thank you, Evie. But I see that you already have a stopwatch, so I'm going to use you as my volunteer. But thank you, Evie. I appreciate that. Now, in the same way that a tornado starts, eventually it has to stop. So everything that comes with a tornado, that vortex, that wind, that rain, that stormy atmosphere, it has to stop. So we're going to somewhat replicate that by trying to see how long and compare how long our different tornadoes in the bottles are going to take in order to take out the water. So I want you to unseal your tornado. Okay. Now we're going to get ready for the start. So pick up your bottles, and we're going to see how long it takes to empty. Ready, set, go. Okay. How many seconds does the stopwatch say?
4.61 seconds.
Okay, so write 4.61 seconds on the time. Now I want you to look at the second column. What does the second column tell us?
Just liquid?
We're going to use dish liquid. So that liquid that we use in order to wash our dishes, we're going to put 1 drop inside a bottle, and we're going to see if that makes a difference. So here's your bottle. Here's your bottle.
Thank you.
Okay. I'm going to go ahead and have you unseal the bottle. Get it set up. Thank you.
You're welcome.
Thank you.
Thank you.
And while I get your water ready, I want you to think about what you think is going to happen with the tornado as we add that dish liquid and water. What do you think that vortex is going to look like? Do you think it's going to be the same type of tornado? Yes.
I think it's going to look really blue, like a real tornado would.
Like a real tornado would if it was in a blue atmosphere?
Yes.
Okay. What do you think?
I think it will form a slight vortex, but not spin too long.
Okay, so again, not spinning too long. Write down your predictions. I get you ready. Make sure that you're writing with a capital letter and you're ending with a period. Okay. Seal up your tornado super tight as you can. Okay, you've written down your predictions. You've made sure to seal up your tornado super duper tight. Now again, I want you to pick up your bottle and I want you to spin it. Okay, I want you to spin it to the right. Spin it a little bit faster, a little bit faster, a little bit faster, a little bit faster. Now look at it. Watch it. See if you see anything. Look under the bottle if you can't see anything.
Yeah.
Ooh, right.
I got some stuff on that one. Still swirling.
Okay. All right, write down your real results. Write down your real results. Okay, so last time we counted our time taking out our tornado from the bottle, we saw that it was 4 seconds. So now I'm going to empty this water from each of your bowls, and we're going to see if there's a difference in time because we have added a different substance. Thank you, Evie.
You're welcome. Thank you.
Okay, so unseal your bottles. All right. You ready?
Yes.
All right, pour. Okay. What does the timer say now?
6.21.
6.21 seconds. Why do you think it would take a little bit longer to empty everything? Yes.
Because it's too bubbly, and if it's bubbly, sometimes it goes really slow.
Okay. Why do you think?
Thicker.
It's thicker?
Doesn't have the water by itself. Doesn't have its substance in it, so it's thicker.
All right. Very good. Now we're going to try a different substance. Barin, why don't you tell me what the substance is that we're going to use now?
Red cooking substance.
Okay. So we didn't have red food coloring because we don't really use that a lot in here, but we did have a red cooking substance. So we're going to prepare our next bottle with a red cooking substance.
Thank you.
So go ahead and unseal your bottle. And we're just going to add some red cooking substance. Now, look at the red cooking substance. What's happening? You think anything different might happen since we again have added a cooking substance?
Yeah, I think it may spin longer.
You spin longer. Thank you, Evie, for raising your hand. What do you think is going to happen?
So, like, if we kept on leaving it there, I think let's see, the air would lift up, and it would go up, and it would go through the air.
Okay. So whatever you think is going to happen with regards to your vortex and your tornado and what it would look like, go ahead and write that down by your P for prediction.
Yes, ma'am. Thank you.
Okay, now seal it up real tight. I want you to take the time to look at it while I empty your bowls for the timing phase of your experiment. But look at it. Think about what you think will happen once it's time to shake it. You're doing something really interesting, Barin. What are you doing?
I'm taking the cover off so I can get a better view.
Okay. So you think that having the clear bottle completely clear would have helped you to see other parts of the last two tornadoes?
Yes.
Thank you.
Mm-hmm. So now what I want you to do is I want you to pick up your bottles. Remember that you have a red cooking substance inside it. Now shake it up as fast as you can to see if there's a difference. Clockwise, Evie. The way the clock goes. Yeah. All right, now look at it. If you didn't get a good job shaking it, shake it again so that you can see it.
Yes, a lot. Still going. Going a lot longer.
Yeah.
See the bubble.
Did you manage to see anything good, Evie?
It turned gray.
Turned a little bit gray to you? What about the actual shape of the tornado? You need to shake it again so you can see?
To me, it looked like a rectangle.
To you, it looked like a rectangle. It didn't look like a vortex.
It looked like a vortex.
Do you need Papi to help you out? Yeah, have Papi help to shake it up.
I see a black thing.
Let him be your partner. Now look at it.
Still spinning.
It's still spinning.
Okay. All right. So now I want you to take your bottle. We're going to see if there's any difference with this red cooking substance, if it makes it faster or slower. Ready? Go.
And faster.
Okay. You think faster, but when we start the timer,
6.8. Yeah,
so it was 6.89.
Yes.
It looked like it was flowing a lot faster than the dish liquid. Why do you think that was?
That no bubbles.
It didn't really have bubbles. Is there a difference between the dish liquid and the actual red cooking substance? Yes?
It's because there was the dishwashing thing. It didn't spin that much, but the red
Cooking substance.
It was thicker and it spun more than the dishwashing.
Okay, no problem. All right, and then we're going to look at our final substance. So this is Mommy's favorite beverage. What is that beverage?
Coca-Cola?
Coca-Cola. So we're going to see if using Mommy's favorite beverage makes any difference at all. So think about what you know about Coca-Cola when you help Mama to pour her Coca-Cola into a cup with ice. Think about what you know about that. Think about what you think would happen. Now sometimes scientists think that they know exactly what's going to happen and how they're going to conduct their experiments, but sometimes scientists really don't. Okay? So because I see that there were some drops of Coca-Cola, but it really doesn't look like it's enough to really help us out, we're going to see if we can unseal and put in some real-time Coca-Cola to see if that makes a difference. So we're going to try.
It's going to blow.
Okay, now seal it up.
I wanted to drink it. I want to see what it
All right,
tastes
seal it up real tight. You made your predictions. Now spin, spin, spin. And look. Is anything happening that you're seeing?
Not much.
I know.
Not much.
It's on the vortex, but it's not as long as cooking substance.
Do you think that we need to add more Coca-Cola to see?
You try.
Let's unseal and see if having more of the bubbly Coca-Cola helps out. Unseal?
I put mine down. It was sparkly.
It was sparkly.
Mm-hmm.
Now try it.
Yeah.
So what did we notice when we added more Coca-Cola?
It popped. It immediately showed the vortex.
It immediately showed the vortex. Did it show the vortex a little bit better than the other substances or water alone?
It showed it better, but it's not as long as the effect wasn't as long.
After, I want to see what it tastes like.
We're not going to taste this one. We can taste the real Coca-Cola.
Yay! Let's taste it.
Okay, and as I get your bowls together, think about how long it's going to take to empty out the tornado.
Should be fast.
Thank you.
All right, so we're going to unseal our bottle. And we're going to see if any difference is made in time. Ready, set, go.
Wow.
Okay, what does our timer say?
8.37.
8.37.
Took the longest.
It took the longest. Do you think that maybe some of the substances, even if they're thicker, they don't affect the water as much, but if they're maybe bubblier, they affect it as much? Or why do you think there was more time?
Bubbly, well, because dishwasher was bubbly and it didn't take as long as the Coke.
Okay. What do you think, Evie?
I think it was the Coca-Cola. It was really slow because it was very, very heavy.
It was very heavy. What do you think? No, I cut you off. I'm sorry.
No, same thing.
Okay, so maybe it was secretly more heavy.
Mm-hmm.
Okay. So, in the real world, probably in my class, I would ask you to go home and replicate with your family and give you a lab sheet and see if somehow that makes a difference. And then we could have an extension and connect two bottles together using the steel flat washers to see if together somehow we can see a vortex in better real time and compare using different food colorings and things. All right, so say thank you to Dr. Annetta for allowing me to be my students. All right.
Bye, have a good day.
Gracias.